Our field is kind of a binary field. It's 0 or 1. It's nothing or all of it. You know, if you don't get the structure, you have nothing.
Structural biology is the study of the structure of biological macromolecules in 3D. We're here at the Max-Planck Institute of Biochemistry in Munich, where Elena Conti's research teams study the behavior of protein complexes using a technique known as crystallography. The first stage of this process is the very difficult task of obtaining protein crystals.
So once they form crystals like this, we transfer them into loops, nylon loops, and here they're frozen at 100 Kelvin. And then from that, we sent to the synchrotron. In this case, we took to Switzerland, the Swiss light source in Villingen, and then we collect these images like this with these dots. So this is the reciprocal space, which means it's the Fourier transform of a crystal containing the protein of interest. From this information, we determine the structure in the computer.
What I'm interested in is to look at these molecular machines and how they drive the life of a cell. And we look at how they are constructed and how this construction at the atomic level, atom by atom, really directs how they carry out their chemical reactions, how they interact with other macromolecules, and eventually how they results in their biological function. It's a long process to solve crystal structures and to get to the structural level. But once you see it, you know, you just understand how it works. And as often you look at it and there is something you don't quite understand, and that is as great, because that is the next question that you're going to go after.
Elena has just very good ideas. I mean, she knows she can use the technology, she can use the methods to her advantage to solve problems. So now the ability is to ask the right problems, because the technological inputs are there and possibilities are there, but you need to find the good questions, you know, pose yourself the good questions. So that makes nowadays a good scientist and a good crystallographer if they know which problems they can approach and how they can use the technology to their advantage.
Elena Conti and her team are particularly focused on the RNA in human cells that create the proteins necessary for their development. It is a complex process, but one that scientists are getting to understand better and better.
I always try to give this analogy of driving a car. You know, an experienced car driver knows when he or she is driving if there's a funny sound that something is wrong with the car. But how do you know the sound is funny? It's because you know what the car should normally sound like. So also it is important for us to know how the cell normally functions, and this is where the merit of basic research lies. It's important to know how this actually works in the cell, that when something goes wrong, you can figure it out quickly, you can intervene, you can treat it, and you can understand it better.
In crystallography, you gain a lot of information at once. So once you obtain the structure of a protein or a protein complex, you have a lot of information which you can make use of. So you get a very detailed picture of what you're working on, and this allows you to ask new questions.
We are the sort of ultimate magnifying glass of nature, because we can really take a snapshot of very, very tiny particles within the cell and resolve them to an atomic resolution, and this is really unbelievably fascinating.
Elena Conti has headed the Department for Structural Cell Biology at the Max-Planck Institute since 2006, following a distinguished career that began in Italy, her home country, then continuing in England, the United States, and finally here in Germany.
I remember feeling that she was very driven, very focused as a person and as a scientist. And I remember looking at her with great admiration, in a sense almost envy, but not envy because I envied her, but just because when you recognize that a person has that drive, you know, you kind of look at them and say, wow, you know, and I remember following her career and thinking, what is she going to do?
I am not somebody who wanted to be a scientist from childhood. You know, for me, in fact, even at university, I was undecided, should I do science or should I do architecture? And then at the end, I decided for various reasons to do chemistry. But even then, research was not really on my radar. It's not something I really knew about. It's something I discovered at the end of my university studies, and this is when I discovered structural biology as a field. And it's a fantastic field because it's really an intersection of different scientific disciplines. It's between chemistry and biology and physics. What it deals with is the architecture of macromolecules, and for me it was a perfect fit. I kind of found my perfect match. And the passion grew since. It's not one moment, it's one step after the other, and the passion has been growing and is growing since then. I love what I do. So this is in 2 and this is in 2 then, or not? I expect the same passion that I have, but I'm also ready to give, both professionally and also personally in the same way. I think it boils down to the fact that the lab is really my extended family, or I see it like this, and I see my people like this.
Elena Conti has built up a team of young scientists with inquiring minds and a capacity for hard work, encouraging them in their daily tasks with careful attention and by setting high standards, but with the natural warmth and friendliness of her Latin background.
When you work on something and you have the feeling you don't make any progress, she somehow finds a way to motivate you, so she is giving you always the feeling that you make progress and you're close to the goal you have.
There are other things you have to keep in mind, like, is your project feasible? Does it fit in with the interests? Is it viable in the long term? Is there a perspective? And these are things that a young starting person might not always bear in mind, or might not even know that you should bear in mind. And I think that's where a good mentor's role really comes in, to gently nudge you in the right direction and to encourage you to do what you can do best.
It's very important to have somebody by your side who says, well, what do we do next? What do we try? We try this one, let's move forward. And, I try to do this because I've been there.
To become an experienced and renowned researcher, being a serious scientist is not enough. Knowing how to get research moving forward, how to manage a project, a team of people, finding the financial support, researchers today can no longer only have their heads in the stars. Their feet must be firmly on the ground in the real world of their particular disciplines. Something that Elena Conti knows only too well, and makes sure that those around her know it too.
At the beginning of my time here, it's been very difficult because I'm not used to being a group lead. I used to be a postdoc. She has been showing me an example of how to deal with difficulty and challenge. So she has been a great mentor in that sense.
Yes, I do think it's important to have a mentor, just also because this is a very, very competitive and tough job. And if you have somebody who you trust and who you feel that they will be your safe haven, and that they motivate you and give you the knowledge, and they can pass on this knowledge, then you feel self-sure and much better equipped to pursue your goals.
So I think it is very important to have a mentor, and Elena is actually my official mentor here at the Institute. We have a mentoring program, and it's very important because there are many things that pop up when you are a group leader where you have no idea on how to respond to this, and this can sometimes be scientific questions, but often it's more like political questions or things with how to deal with publishing, how to deal with collaborators, how to deal with competitors. And there it's very important to have an experienced scientist that might be able to sort of guide you through the process, and also to calm you down when you think that something is going horribly wrong.
The future in the field is very exciting. Already now, what we are looking at is we can look at machines that are present in very low amounts in the cell, that are often transient. They're always dynamic. And so we can reconstitute these transient machines in quantities and impurities that we can then go for high resolution, and we can look at the atomic level what happens. And so this is already happening, and it's going to happen more and more. It's going to be challenging because in the past traditionally there had been experts in a single type of disciplines, and these days are over or soon over. The future is much more interdisciplinary, and it's going to be challenging because each of these technology, each of these disciplines is demanding if you want to understand what you're doing. And if you want to go for difficult projects, you have to understand what you're doing.